Finally, let's implement the search operation. So public int, because we want to return the index of the given item, we call this method indexOf and give it a parameter item. Now, what should we do here? We want to loop over all the items in this array. If we find the item, we want to return the index. Otherwise, we're going to return -1. So once again, we're going to use a for loop. That's pretty easy. For I, we set this to 0. As long as I is less than count, we're going to increment it by 1. Now we need to get the item at the given index and compare it with this item. So we write an if statement. If items of I equals this item, then we want to return I as the index. Otherwise, if we finish this loop and we're still here, we didn't return from this method, that means we couldn't find this item. So we should return -1. Let's test our new method. Back to the main class. We added these 4 items, 10, 20, 30, 40. Let's print numbers.indexOf 10. So that is 0. Beautiful. What about the index of a number that we don't have? Let's say 100. That is -1. So we're done with this implementation. But before I remove the comment, let me ask you a question. What is the runtime complexity of this method? Pause the video and think about it for a second. Okay, here's the answer. We need to analyze the best case and the worst case scenario. The best case scenario is where this item is the first item in this array. So in that case, the runtime complexity is O of 1. But the worst case scenario is where this item is at the end of the array. So we have to loop over the entire array to find that item. If our array has 1 million items, that means we're going to have 1 million comparison operations. So in the worst case scenario, the runtime complexity of this method is O of n. As I told you before, when doing big O analysis, we always consider the worst case scenario. So the runtime complexity of this method is O of n.